Good morning, students. This is Anjali, Assistant Professor of Institute of Aeronautical Engineering, Hyderabad, Department of Computer Science Engineering, AIML. Today's topic name is Data Discretization. Before move to our topic, first we will recall the previous session in shortly. In last session, we have seen numericity reduction, where we have learned that we can reduce the data by using the some methods. That means we are converting our data from large number of data into the smaller form of data, where it contains the two types, parametric and non-parametrics. In parametrics, which will focus only on parameters where our data we want to fit, and it will contain the only models like a regression model and log linear model. In regression model, we will use some equations where it will use for us. It will use some attributes which are attributes like input and output. For example, we can see y is equal to wx plus b. Here, y is our dependent variable. Y is our dependent variable and x is a independent variable, and w and b are regression coefficients. That means here in parametric methods we have to focus on our parameters, we have to focus on our models. Then in log linear model, here a log linear model is used to estimate the probability which are used for reducing the methods. And now we will move to non-parametric. In non-parametric method, there is no need to focus on your data, no need to focus on your models and parameters. You have to focus on your data. That means you have to store that data in the form of data cube aggregation. Even you can save your data in the form of clustering, sampling and histogram. In data cube aggregation, we are storing the data for analyzing and estimating the data. That means you are storing the data in the form of only cube. If someone asks you for average of your company selling, average of a company selling, then you have to find out only that result. You will not store or you will not show that data. You will not submit the whole thing. You will submit only the average. And it is very easy for user to find out the average of selling data, selling the products. Then clustering. The clustering means you have to put the data in the form of group. That means you will search for the similarity and dissimilarities of the data. That means after finding out the similarities and dissimilarities of data, you will store that data in the form of only group. Then sampling. In sampling, you are keeping the data in the form of some intervals. That means there should be without replacement, with replacement, then some stratified sampling. There should be some clustering sampling. That means if you have used some data before, then you can't repeat that data again. This is sampling without replacement. Then with replacement, that means with replacement you can use the data again and again. With sampling, duplication of data is possible, but without sampling it's not possible. That means in sampling without replacement, with replacement, clustering sample and stratified sample. That means you are putting in stratified sample, you are keeping your data together. After that, you are searching for similarities and dissimilarities. Again, you will search for only that data which is we need. That means the remaining part you will discard it. Then clustering sample, You will, in clustering sample, you will search for only similarities and dissimilarities of data and you will keep that data in the form of group. Now, next topic was the data transformation, which is used to transfer the data from one form to the another form. For example, we can say if we have written some document in the Word and that document we are storing in the PDF format, that means we are converting the Word into the PDF. This is the data transformation. That means you are transforming the one data format into the another data format. Here are some strategies which are smoothing, aggregation, discretization, generalization, normalization, feature construction, concept hierarchy generation, and accurate data and accurate results. In smoothing, you are removing the noise data. In aggregation, aggregation is allow you to perform some operations. Then in discretization, you are keeping the data in the form of interval. Then generalization, in this you are transforming your data, your high level data in low level data into the high level data. Then normalization, you are converting the some variable into the smaller format. Then feature construction, you will find out the some newly features which are very useful for users. Then concept hierarchy generation, you will keep the attributes in the form of hierarchy. And then accurate data and accurate result. After transformation and after applying all the methods, you will get the accurate data and accurate results. This is all about the numerosity reduction and data transformation, which we have covered in last session. Now, in this session, we will start the data discretization. First, we will see introduction, then discretization of the top down, then discretization of the top bottom, then techniques of data discretization and feature generation. First, we will see the discretization. What is discretization? It is the process of converting your continuous variables, continuous models, and or we can say continuous functions into the discrete format. That means in the discretization, we are converting our some data into the discrete format. That continuous data, we can say the continuous data means which are used for measuring purpose. We are not counting, we are measuring purpose. For example, we can say continuous data it is used for measured purpose. We can say it is like 6 kilometer, 7 kilometer, 7 centimeter. This is the continuous data, and these data you have to convert into the discrete format, discrete data. And this discrete data is only counted purpose. We can use for the counted purpose. We can use this data for the counted purpose. Continuous purpose is used for measured purpose and discrete data is used for counted purpose. For example, 100 people, 7 kids. That means these things we can count, but we can't measure. And these things we can't count, but only we can measure. That means we are converting the one form of data into the another form of, and that we can say continuous variables, models or function we are transferring into the discrete format. Then what is discretization? What is data discretization? It is the method of converting huge number of data into the smaller ones which are very useful for evaluation and management of the data. And in other words, we can say we are transforming our continuous data into the finite set with the minimum data loss. Now we can say this is our table ID, name, phone number and address. But before going to this example, I will again repeat the data integration technique. It is the minimization, it is the process of minimization into the small forms from continuous attribute by dividing data into the intervals. That means we are dividing our data in the form of intervals. We can say this is table and this table is containing some values, and we will give some attributes 1, 2, 3, 4, 5 and so on. Now what I will do here, I will split the data. In data discretization, you have to split the data and after that you have to give some specific value on for that particular interval. And we are splitting that data in the form of interval. For example, I am splitting that data. I splitted this data and I got some intervals like this is interval 1, this is interval 2, this is interval 3. That means I will get so many intervals. But after getting some intervals, I have to replace that interval by using some specific value. By using some specific value. That means I will replace this form by using some specific value which are our interval labels. Which are our interval labels. That means I will keep here interval label 1. Then this is second interval. I will keep here interval label 2. That means I am replacing that interval by using some interval labels, by using some specific value. This is all about the data discretization. Now again we will see one more example of data discretization. Here I kept some values. I have taken some values as a age from 10 to say 75. Now I have to apply. First I have to split that data, and after splitting that data I will give some specific value. Now I can observe that till 19 I splitted this data till 19. After that I splitted this data till 42, and another interval is 70 to 75. That means I got this interval first, second I2, and this one I3. Now I have to give some interval labels. Then I have decided after discretization these are the related to age. So I kept as an attribute young. 10 to 19 are included in the young. Then 30 to 42 it should be mature, and 70 to 75 this is the old. That means I used some interval labels that are young, mature and old. These values are covered all things. These attributes are covered all the data. I didn't remove anything. There is nothing loss of data. There is only we splitted that data and we given some specific values. Now we will see that discretization has some approaches. Data discretization has some approaches on the basis of class and on the basis of direction. When we are thinking about the direction, then it should be two types: top down and bottom up. Top down and bottom up. Actually, in top down mapping, starts from the top. In top down mapping, it starts from the top and it will go through that means it will travel to the bottom. That means top to bottom, and when it will start from the top, it will start with some general concept, and on the bottom we will get some specialized concept we can say that as a result. We can say that as a result. And if the procedure begins by first finding one or some points, definitely first we have to divide that set of attributes. That means in top down we are splitting our data. In top down we are splitting our data. Actually, when we are talking about the top down and bottom up, in top down you have to split your data, and in bottom up you have to merge your data. And when you start it from the first interval, then it will start to divide your set of attributes and then perform continuously, recursively. It will perform recursively, it will repeat till the end, till the resulting intervals. And this is called the slicing. This is called the slicing. Even in this point, here we can say this is the slicing, or you can say it is our cut point. It is our cut point. Now we will see some example from top down. For example, we have a set of attributes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I will first split this data. I split data. Then, after splitting this data, I got the one data set. I got one data set. Again, I will split this data from here. Again, I got some data set. This is, we can say, the general concept. This is general concept of data. But when we will get the result, it will be specialized concept. Again, I will split this data. Now, again I will get another data set. That means till the end we have to repeat this process till get the specialized results. That means at the bottom of the data set we will get some specialized concept. We will get some specialized concept. That means here in discretization of top down, you have to start from the top. You have to start from the top and you have to travel to the bottom. When you will start from top, that means your data set will contain some general values. Your data set will contain some general values. And when you will reach to the bottom, at that time, your data set will contain only specialized values. Only specialized values. This is the top-down approach. Now we will see bottom-up approach. Bottom-up mapping starts from the bottom, and it will travel to the top. Here, that bottom space, your bottom the data will be specialized concept. Your bottom data will be specialized concept, and it will move towards the top for getting the generalized concept, And if procedure begin by considering all continuous values, that means you have to first split points and remaining attributes you have to discard. And remaining attributes you have to discard by combining the sum intervals, and it is called the merging. I already told that in top down approach you are splitting your data. In top down approach you are splitting your data, and when you are using the bottom up approach you are merging your data. You are merging your data. That means in uh, discretization of bottom up, you will start from the bottom and it will go to the top. And when you will start from bottom, it will contain some specialized content. It will contain some specialized data, and it on the generalized concept. It will involved in only top of the data. Here you have to first split your points, and after splitting you have to merge that data. Now we will see example. Let's see, we have some attributes. Now I am splitting this data. First, what I will do? First, I will merge this data. Then, already, first you have whatever you have, first you have to split the data, and after splitting you have to merge that data. Again, that splitting data you have to merge. Again you have to split. That means you have to merge this data. That means in discretization of the bottom up approach, you have to focus only on merging. We are not focusing on splitting of the data. We are focusing on merging of the data. Now, we will move towards supervised discretization. I already told that data discretization has two approaches which are totally depends on class and direction. When we will talk about the direction, then definitely it will contain top down and bottom up. But when we are talking about the classes, then automatically it will contain two types: supervised discretization and unsupervised discretization. Supervised discretization. When we are processing on the data, at that time, that model has some information of your classes. That is the supervised discretization. According to a definition, when you take the class into the account when making discretization boundaries, which often a good idea. That means when you are talking about the supervised discretization, it will always get to know it has already information about the class. Actually, supervised discretization here, model is already trained. here model is already trained, it and it has a very clear idea about the idea. It has a very clear idea about the classes. That means that it has already information about the class. And in unsupervised method, unsupervised discretization, it has no any idea of the class, because it is an untrained model. It is untrained model, and mostly it works on the top-down splitting strategy and bottom-up strategy. That means splitting and merging. So unsupervised discretization work on the splitting and merging only, and it has no any idea. It has no any information about the class. It has no any idea of the output. But in supervised, it has already idea of the output. That means, for example, we can say supervised and unsupervised. We have some fruits like apple, cherry, banana, orange, and we can say uh, apple, cherry, banana, orange, and guava. In supervised model, for example, we can say f of x is equal to f of x, and y is equal to, and y is the output, f of y. That means in supervised discretization, already model has information of the output. Already has information output. What will you get the output? It's no. But in unsupervised, it has no any idea of any output. That means these are the input and this is the output. Here only model will take the input and it will give the output according to your conditions. If this machine wants the list of fruits, then what will say? It will directly display the list of fruit. That means cherry, banana, orange, and guava. That means it knows, it has already information about the classes, what will be the output. But input, when we are asking in to unsupervised model, at that time, it if we ask for red for red color fruits, then what it will do? It will search one by one and it will give the output as apple, then cherry. But if we ask for to unsupervised model for red but size is small, then what it will do? It will give the output as a cherry. That means when we are working with the unsupervised model, then that model is depend on totally on your conditions, not on your data. It will depend on totally on the condition, and it doesn't contain any trained model. It has a trained model. It has only working on the conditions, and supervised discretization. It has some information about the classes and it already known about the classes and output, and it can give the information it after training. That means we have to train that model for of this in the supervised discretization there. And in unsupervised discretization, there is no need to train the model. It is untrained model. And in supervised discretization, your model will be trained. That's why it knows everything about your data. But in unsupervised model, It will not give. It will not. It is not the trained model. It is only depend on your conditions. Whatever you are doing, on that basis, you will get the output. Now we will see the techniques of data discretization. First technique is the histogram analysis. What is histogram? It is the graph which shows the frequency of material data, frequency of numerical data which are using rectangles. That means we are showing the frequency of data, frequency of numerical data by using the rectangles. The rectangles can contain the height. That means that height of rectangle can represent this some frequency, and some variable we can also show on the x-axis. That histogram containing the histogram we have to show on the x-axis and y-axis, and we have to plot that data on the our graph, and we have to show that data in the form of rectangle, which will underline frequency distribution of a data set of a continuous data. And histogram help to inspect our data, for the distribution of data. For example, we can say distribution representation, some outliers, some skewness representation you can show on the histogram. Just see, this is the diagram of histogram. It's containing y-axis, as this is x-axis. This is some frequencies. That means here we have shown that data in the form of rectangles, and mostly I already told that histogram stored your data in the form of bins, and this width will not change. This width of the data, this width of the rectangle or this width of the histogram will not change. The height of the rectangle change according to it the frequency. This is techniques of data discretization. And automatically when you are showing your data in the form of histogram, then that data is storing in the form of bins, or we can store that data in the form of bucket. And this is the transforming our data into the small form. We are transferring large amount of data, large volume of data into the small volume of data. Now we can see binning. Binning is the smoothing technique which will help to convert our data from huge number of values into the smaller number of values, and that original values mostly we will divide into the small intervals, which is known as the bins. We are dividing our large values, original values, into the small intervals, and then we will replace that value by using some specific value. For example, we have some students data that containing the marks of the students, and they are showing by the some grades, and that bin will show by some grades. We can say grade 1, grade B, grade A, grade B, grade C, then D, F, like this. That means we are showing the bins as grading. We are showing our bins as a grading point. For example, we can say we have some data which are containing the values 0 to 28 randomly, but equal weight. I divided this data by using some equal width and equal frequency. Equal weight containing bins. Equal width, on the basis of equal width, I have divided that data. 0 to 4, bin 1, bin 2, bin 3. I stored this data in the form of bins, and I've created the bins. Bin 1, 0 to 4. that means less than 10. Second bin 10 to 20, 12, 16, 16, 18. This data will store in the bin 2. Then 24, 26, 28. This data will store in the bin 3. That means I divided this data in the form of less than 10, 10 to 20 and 20 plus. Then I divided this data, I kept the data in the form of interval or in the form of bins by using equal frequency. Equal frequency, first frequency was less than 14, which are covered in the bin 1. Bin 1, 0, 4, 12. Then bin 2, 14 to 21, 16, 16, 18. And bin 3, 21 plus bin 3, 24, 26, 28. Now, we will see cluster analysis. It is the technique used in machine learning which attempts to find the clusters of observation. Main goal of cluster analysis is to find a cluster. And when we are talking about the cluster analysis, obviously that cluster will search for similar to each other and dissimilar to each other. That means it will search for only similar observation, and if they are similar, then it will come together. This is the cluster analysis. Now, correlation analysis. In correlation analysis, it will discover some relationship. It will show some relationship between two variables or two data sets, and it can show that how strong that relationship may be. That means correlation will be shown between two variables. Either that relation should be positive, that correlation should be negative, or there should not be any correlation. For example, let's see positive correlation. In positive correlation, always these variables, these both variables move towards the same direction. And if one variable leads, then automatically another variable also will lead. Automatically increase. For example, if you spend more time on the treadmills, then automatically your more calories will burn. Now, negative correlation. In negative correlation, these two variables are will move in opposite direction. That means if any one variable will increase, then automatically another variable will decrease, or vice versa. For example, if you increase the speed of the vehicle, then automatically it will decrease the time you take to reach your destination. Then weak or zero correlation. That means any variable, number of variables are available, that variables will not affect each other. No effect on another variable. For example, if you learn in one of the school, and you attain the school some years, but after leaving that school, it doesn't affect on your name. That means this is the correlation. This is the no correlation, zero correlation, or you can say weak correlation. According to diagram, we will see this is the positive correlation. Your data is moving in one direction. In negative correlation, your data will move like this. That means in opposite direction. And no correlation, that means there will be no effect on each other. This is no correlation. Now we will see decision tree analysis. In data discretization, always perform some slicing and merging, top-down slicing and some merging data. We are splitting and merging the data. In decision tree, you have to perform some approaches which are used for the supervised procedure. For discretized numeric data, first pick out some attribute which has the lowest entropy, and after that you have to break it, and you have to repeat this procedure till the end, till we get the result. Then concept hierarchy of our nominal data. We can say nominal data or nominal attribute are some unique values which does not contain any order. For example, job category, age category, geographic region, some item category. All these are nominal attributes. And by adding group of some attributes, nominal attributes from definition hierarchy. For example, we can see if someone asked you about address, about home address, then obviously you can say you will say some number of things like city, country, then society, and then plot number. All things you will say, and this data can be stored in the form of hierarchy form. Now we will see feature generation. What is meant by feature generation? Actually, feature generation is also known as feature construction, feature extraction, or feature engineering. It is the process of transforming the features into the new features which are very related or which are very useful for your result, which are very useful for your outputs. That means that feature represent the measurable piece of data, measurable piece of data like name, age, gender. These are measurable piece of data which we can say features we can store in the form of the column. This involves some features, and with this can involve mapping a feature into new feature using some functions like log, or creating new feature from one or multiple features using some multiplication and addition. We can say it is the process of creating new features from one or multiple feature for our statistical analysis, for our perfect target, for our perfect output. This process is adding mostly new information into the your model for making it more accurate, and it will improve your model accuracy and model performance when there will be the interaction between the features. And here two or more features can interact for combine the data, and then you can get the sum of individual effects, and it is possible to interaction with three or more features, and sometimes the result can diminish the output. There are some goals. There are two main goals of the feature generation: dimensionality reduction and accuracy improvement. When the goal of feature generation is dimensionality reduction, then it will result the feature space which contain less features than the original feature space. That means that data, that important data will be stored in the less space. We can save your space. And when you are talking about the accuracy improvement, then your it will contain the more features than the original features. It will contain some more new features, some important features than the original features. For example, we can say this table contains some values: date, visitors. Why I'm mentioning only date and visitors? Date is our original features, and visitor is our dependent features. Date is our independent feature and this is dependent feature, where it's containing some data, visitors to the park, and we have to find out on which date visitors can visit, and that day is weekend day or not. That means we can say first 25/17 there are so many visitors. Why there are so many visitors? Because it's a weekend day. That's why I kept it here yes. Then second one, no. Yes, no. That means where we are kept yes, on that day it is the weekend day. Why we got this conclusion? Because date and visitors are related with each other. Date is independent variable, independent attribute, and visitors is the dependent attribute. On that day, visitors are more. Why visitors are more? Because it was the weekend. That's why there were the visitors more. That means we are deciding on this basis that it is weekend day or not. And we can find out the some pattern where number of visitors is significantly higher on weekend days than on weekdays. Here date and visitors totally both are depend each other, and even we have created the new feature. Here we have created the new feature. We generate the new feature which is weekend day. When it will be weekend day, and how we get to know? Because on that day there were so many visitors and that date was weekend day. So on that day there were so many visitors. So we generate new attribute, and this attribute is more very important for our output. This is all about the feature generation. Today we have seen data discretization, some its approaches, some techniques, and goal of feature generation. There are some references, you can follow it. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.